Welcome to True Projects. In this video, we are going to explain about project titled Credit Card Fraud Detection using Random Forest and Cart Algorithm. This project should emphasize the importance of detecting the fraudulent activities in credit card transactions and obstacles associated with such detection and the specific goals of the project. It also mentioned the utilizing of data source such as the Kaggle dataset and underscored the significance of employing the machine learning algorithm to achieve the accurate and efficient fraud detection. The aim of this project is to create a system for credit card fraud detection by utilizing the random forest and cart algorithms. The primary objective is to train these algorithms using a dataset of credit card transactions and assess their effectiveness in accurately identifying the fraudulent activities. By implementing these algorithms, the project intends to enhance the detection and prevention of credit card fraud, ultimately improving the security and reliability of financial transactions. The basic requirements needed to build this project are hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement, Python IDE with version of 3.7. These are the modules that are implemented to build this project. And the first module is upload the credit card dataset. This module involved the uploading the credit card dataset, which is obtained from the Kaggle website. The dataset contains information about the credit card transaction, including various features and corresponding class labels indicating whether a transaction is normal or fraudulent. And the second module is generate, train and test module. In this module, the dataset is divided into training and testing set. The training set is used to train the random forest and cart algorithm, while the testing set is used to evaluate the performance of the trained model. And the third module is run random forest algorithm. This module focuses on running the random forest algorithm on the trained dataset. Random forest creates the decision tree on randomly selected data samples and combines their prediction through voting to determine the final classification. This algorithm is applied to detect the fraudulent transaction in the credit card dataset. And the fourth module is run Smoothie algorithm, that is synthetic minority oversampling technique. Is an oversampling technique used to address the class imbalance in the dataset. In this module, this algorithm is executed on the training dataset and generates the synthetic samples for the minority class, that is fraudulent transactions, by interpolating the new data points between the existing minority samples. This helps to balance the class distribution and improve the performance of the fraud detection model. And then run random forest with Smoothie. In this module, the random forest algorithm is trained on Smoothie resampled training dataset. Random forest creates an ensemble of decision trees and combines their prediction to classify the transactions as normal or fraudulent. By utilizing the smooth balanced data, the random forest model can effectively learn from both the majority and minority classes, which leading to improved fraud detection accuracy, and then detect fraud from test data. And this module involves applying the trained random forest model, which was trained with Smoothie, to the test dataset. The test dataset contained the transaction data without class labels. The random forest model predicts the likelihood of each transaction being fraudulent. By analyzing the model's prediction, the module identifies and detects the fraudulent transaction in the test data, and then clean and fraud transaction detection graph. After running the random forest algorithm, this module involves analyzing the results and generating a graph that displays the clean transaction and detect the fraudulent transaction. This graph provides the visual insights into the accuracy of algorithm in identifying the fraudulent activities. And the final module is accuracy comparison graph. In this module, we generate an accuracy comparison graph to evaluate and compare the performance of different models for credit card fraud detection. The graph provides the visual insights into the accuracy achieved by various algorithms or techniques used in this project. The execution of this project. this folder consisting of 3 files. The first file is dataset folder. Here this folder consisting of credit card, that is the dataset we used, and the information of the dataset and the test data we used. And the second one is credit card fraud. Here it is a Python file which consisting of the Python code, and it is an run.bat file which is used for the execution of this project. For this we need to double click on run.bat file. And we get a screen like this. In this screen, click on upload the credit card dataset button and select the credit card and click on open button, and we get a screen like this of dataset is loaded, and click on generate train and test model button. Here it generating a trained model for random forest classifier. Here it get a total dataset size of this, and here it split the dataset into the training and testing part of this number, and the total cleaner records that are found in this dataset is of 284315, and the total attack records found in the dataset is 492. And click on run random forest algorithm button. Here it generates the random forest model on the train and test data. Here it gets an accuracy rate of 99.78, and click on run smoothie algorithm button. Here it generates the smoothie algorithm on the train and test data. Here the total clean records found in the dataset after applying the smoothie algorithm is of 284315, and the total attack records found in the dataset after applying the smoothie is 284315. And click on run random forest with smoothie. Here it generates the random forest model with smoothie on the train and test data. By this it will get an accuracy of 29.625, and click on detect fraud from test data button and select the test data from it and click on open button. Here we get a screen like this, where the square within the square bracket represents the data of it, and the result as predicted transaction contains the cleaner signatures, and we can scroll down it. We can contain some of the information such contains the fraud transaction signatures. In this way we can detect the fraud from the test data, and click on clean and fraud transaction detection graph. Here this is a graph represents of the x-axis total transactions, normal transaction and fraud transactions, and the y-axis represents the values assigned to it. And close this graph and click on accuracy comparison graph. Here the graph that represents the accuracies of the models we used in this project. Here the x-axis represents the names assigned to the models we used in this project, that is random forest accuracy and smoothie random forest accuracy, and the y-axis represents the values assigned to the each accuracy rate of that model. In this way we find the accuracy comparison graph and then close this graph. Finally, in conclusion, the random forest and cart algorithm provide to be effective in detecting the credit card fraud by training the model on a dataset of credit card transaction. The system achieved the high accuracy, precision, recall, and F1 score in identifying the fraudulent transaction. The use of these algorithms enhances the security of financial transactions and help in reducing the financial losses associated with credit card fraud.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.